Hey guys, welcome back to Computational Biology with Python. I started this video, well this is the second half of the tidying up video, or not tidying up, the second half of the composing functions video, and then I had this huge brain fart while I was setting up of where I stored my files. So I had to go find my files. Remember, we did a good way of using the terminal to find your files, which I did use. I could have recorded it, but I didn't, because I didn't know how long it would take me to find them, and I want to keep these videos 20 minutes. So anyways, we're going to continue on, and we're going to do some function stuff with our inflammation data. So let's start it up. Okay, so first things first is I want to create this Python thing, and I could not remember. I was looking, you can't see it over here. I'm gonna make this that's not gonna help either. Okay, well if I go down far enough you'll be able to see it. Alright, SWC, Software Carpentry Python, is where the files are, right? For the inflammation stuff, and then we go into data, and this is where all of our inflammation stuff. I was looking in our ocean data that we used earlier, and I was like, why isn't it in here? It didn't make sense. Okay, so now that I have found it, Python 3, so I see I have a new file in here. I'm gonna save this as something different. We're gonna call this one, remember to save it over here. Let's save this as creating functions part 2. Alright. Okay, so let's do this. Let's create a function to make our inflammation this is a rough night recording videos. Inflammation analysis easier to read and easier to reuse. So let's visualize our file name, and we'll say data equals, remember, equals numpy dot load txt fname equals file name delimiter. So what is separating the data values? And we're going to say it's a comma, and then we're going to say our figure. So we're going to plot some stuff. Matplotlib.py plot figure. We're going to say our fig size is equal to, say 10.0 and 3.0. This should be a point. There we go. Okay, so our axis 1. So we're gonna plot this out. So we want fig add. We want to subplot 1, 3, 1. So remember, we're saying this is a 1 row, 3 columns, and then our first position. Then axis 2 is the variable that we're going to define our fig add subplot 1. So the same thing, 1 row, 3 columns, but this is our second position. And then axis 3 is fig add subplot 1, 3, so the last position. Okay, and then we're gonna say we have to do our titles, set ylab label, sorry ylab, that's a R thing, average, axis 1 plot, numpy mean of our data, axis equals 0. So the nice thing is with this function, what's going to be able to happen is you can feed it any data and it's going to make this plot, right? So it's a function for plotting, and you can use multiple different input data. So whatever input data fits, it might have to be ordered a certain way, but you can not have to write this over and over again. So if you have so in our case we have what, 12 inflammation data sheets, so it should work on all 12 of them. It'll save us time. Access to, where am I at? Set y label. We're going to say this is max. Dot plot numpy dot a max data axis equals 0. And then we'll do the third one. Access 3 set y label min and access 3 plot. You can see the pattern here. NumPy, we're going to say a min instead of a max. Data axis equals 0. Then we're going to say fig type layout matplot dot py plot dot show. Okay. I'm assuming. Oh, okay. Let's see. Now we're going to make another function. Don't worry, the payoff is coming. So we're going to define detect problems for file name. We're going to say data equals numpy load txt fname equals file name delimiter equals, so this is the same thing, just saying what kind of data it's going to intake. If numpy dot amax for the data we give it, axis equals 0. If the value is 0, or if the first value equals, remember, so this is saying, okay, if for our Amex data, the first value is equal to 0, and numpy Amax data axis 0, 20 equals 20, we're going to print suspicious looking maxima. And then we're going to say elif, or our alternative hypothesis, so to speak, or line of code actually. So if numpy, if 0 equals 0 and 20 equals 20, we're going to say it's suspicious looking data. That's just to say that it's likely that we just have line numbers, right? And not actual data. So a max doesn't make sense to include if it's just line numbers. Like, what's the point of that? We already know the line numbers. So alternatively, if the sum of numpy a min data axis equals 0 equals 0, print minima add up to 0. And we're going to say else print seems okay. Okay, so what this is doing is if the sum of our min data is 0, that likely means that our data is all messed up, right? Because our minimum should not, the total number of all of our minimums are likely not 0. So it might be something suspicious. Let's see. All right, so now, so we're gonna run this syntax problem. There we go. Okay, now what we're gonna do is file names equals sorted glob inflammation, and then we're gonna put a star. Remember, that's a regular expression. That means inflammation anything dot CSV, because all of ours are inflammation -03 -04, so we'll just take anything that starts with inflammation. And we're gonna say for file name in file names through 3 print file name, visualize file name. Remember, visualize is this function we made up here. And then we're going to say detect problems for file name. Glob is not defined. Let's see. I think we're missing some libraries. So let's put up here import numpy. Actually, I'm going to let's see. Actually, I'm going to cut this. I'll put it before our, right here. Oh. Alright. Let's try running this. Glob is not defined. Why are you not globbing? Oh. All right, let's try import glob. Oh, forgot to import a lot of stuff. Import matplotlib. pyplot. So I'm going to cut, oops, edit, undo. Oh no. Oh no. Redo. Alright, well, I just lost that text. So the very top of this here, I'm going to put our import numpy, import matplotlib, import glob. Okay, and I'm gonna run these. I'm gonna run this, and I'm gonna run this. All right, and then I accidentally deleted this, so I'm gonna put this back, and I'm gonna run this. All right, what am I missing? Matplotlib has no attribute pyplot. Why are you saying that, Matplotlib? Let's see. Oh. Okay. And we need to import matplotlib.pyplot separately, I guess. Okay. Now let's run these. Hey, it worked. Okay, so it did all of our data it just did the first three. So since we did for file name and file name, so we said just take the first three. You can see 1, 2, 3 times. So it did CSV inflammation 1, 2, and 3. If you got rid of this, and if we run it again, for file name and file names, it'll just go through and do all of them. So if you want to see the difference, that will work. You can go all the way up to, what is it, 12? 10, 11, 12. Yeah, so that works. Just remember to import the right libraries. Because we started and stopped, like this is a part 2, we didn't have any of this loaded anymore, but we just need numpy, matplotlib, pyplot.pyplot, which is separate. It doesn't automatically get imported with matplotlib, which I didn't remember. And then glob. So if you want to put a chunk up at the beginning here, you can insert this cell and then you can just slide them around. So if you want to put a new one, or you can just put it at the top of this one here too. And if you want to get rid of it, delete cell. So there we go. I have no idea how much time I'm at because I was messing with my figuring where stuff is. So I guess we'll do one more here. Okay, let's do some actually, we're gonna stop here. We'll do the next video here. Okay, this might be a short video. This might not be a short video. I don't know until I edit out all my figuring out what was wrong with my code. Such is life, as they say. So that is the end of this video. We will continue with our functions, and we'll do testing and documentation of our functions in the next video. And so we're getting through functions. Functions, they might seem kind of like, what's the point is? It saves you a lot of repetitive tasks. I guarantee that as students, you've done something where you had to go through every line of an Excel spreadsheet and like add a point, a decimal point, or capitalize something or something like that. These functions will save you having to do that. And remember, some of our data sheets for like Arabidopsis, so an organism I work with, it's like 23,000 genes. So you'd be doing it for weeks going through and changing things. So they're very powerful, very useful. So bear with us. We'll get into testing our functions in the next video. If you're watching on YouTube, hit like, hit subscribe. If you're one of my students, hit like. You guys aren't hitting like on my videos. It does help get this out there on YouTube, the algorithm. So I won't give you bonus points, but I'll give you love and appreciation points. So anyways, thanks for watching. I hope you enjoyed, and I'll catch you in the next video.